Okay, so once again you are mostly welcome. We are now in for item 010, or simply you can just call it item 010. Please, it is coming from topic light. All right, good. And now you see proceeding with our revision series, and now we are in for item 10. And now that means that please, we have right there from item 001 up to where we are right now. So you visit the playlist and you check for UCE physics revision items. We have chemistry, we have math uploaded on the channel already. Okay, good. So we simply remind you to subscribe to the channel, and please, in case of anything, you can hit my inbox. The number is right there at the bottom. In case of anything, or anyway, whatever the case, you can inbox. It is the very number on WhatsApp. All right, good. So without wasting time, let's get there. Alright, good. So remind you to subscribe, share, like, and comment. Right, good. And without wasting time, I think let us proceed. Alright, good. Let's get the question. Now, before we attempt our question, please, at Ores, it is our culture that whenever we happen to end every video, we put for you another video which may be important. So watch up to the end such that you see our other videos which are on the channel. Okay, we know we have a lot of the videos here, so it is a bit very difficult for some people to access them. So we always make sure that at the end of every topic we attach a video for you. All right, good. So at the end of every video we attach a video, another video which may be important. So at the end of this we are going to attach for you specifically the videos about set theory. Please be there to watch them. There is always a learning point in every item which comes about. Alright, so without wasting time, let's start off. They're saying the mother developed a dental challenge but could not identify the exact tooth that should be extracted. Extracting a tooth. That's not really good anyway. Even after checking using her phone mirror, she decides to go to the dental clinic. In the dental clinic, a small mirror was used and the tooth was easily identified. Okay, this made the mother to be more interested in the mirror, and on checking, it had the following ratings: radius of curvature 20 centimeters. Now of course, by saying this one radius of curvature, it means that you're going to deal with a curved mirror. That word curvature, the mirror they were using was a curved mirror. Radius of curvature 20 centimeters. Okay, when she placed her face about 6.0 centimeters in front of the mirror, her face appeared different with bigger eyes and nose, which left her wondering. Good. As a physics student, but make use of ray diagram to explain how the mirror in the clinic is different from the mirror from the one at home and how it works. We shall go into that. Okay, use a graph to support your explanation to the mother about the nature of the image of her face when she tried to look through it. All right, good. So here we are going to specifically talk about mirrors in simple terms. And now let's underline some things here. Remember, now at home she used her phone mirror. Please, let's underline this. A phone mirror, that one acts more like a plane. Acts more like a plane mirror, by the way, if you are not mistaken. This acts more like a plane mirror. So let's cut that. So in here we shall need a plane mirror. The next, what are we saying here? A mirror. She saw the mirror they used in the dental clinic had the writing radius of curvature 10 centimeters. Now if it has radius of curvature, then expect two things. We can either have a concave mirror like that, or we can have a convex mirror like that. But you all know that when dealing with the dental clinic, we always use a concave mirror to so we always use the concave mirror. So this one is this one here is concave. Let me use the word concave here. This one here is convex. convex mirror. So we're going to talk about a plane mirror, which can appear like that, and a convex mirror. And now want to see the image formation in a convex mirror, and rather in a plane mirror, and the image formation in a concave mirror is the one at home. The plane mirror. Okay, the plane mirror is the one at home, and the concave mirror is the one at the right clinic. So I think let's go and start off with that without wasting time. Let's go there. Okay, good. Now what you must know here first of all is, when you have a plane mirror in this format, how does the plane mirror work? In fact, let's see here. We want to see how does a plane mirror work in simple terms. How does a plane mirror work? In fact, here, when you have a plane mirror like this, assuming this is our plane, okay, this is our plane mirror in simple terms, just accept that that's our plane mirror. Now, a plane mirror, assuming if you have a body here, an object here, what you should know is that, all right, rays from the object strike the mirror at a certain angle like that. Now it strikes the mirror at a certain angle like that. It means that these rays, from laws of reflection, this ray will be reflected back in that order using rays of laws of reflection. And what happens is, when you look at this ray here, I'll use this. This ray, when you look at it, it appears as if it is coming from a certain point behind the mirror, a certain point behind the mirror, a certain point behind the mirror, like that. Okay, it appears as if it's coming from a certain point up this side, like that, like that. And now this becomes the object, this becomes the image. The property should be okay. So that's how the image is formed. Now here, look, here I'm using what you call a point. I'm using what you call a point object. I'm using what you call a point, all right, object. Now what if when, I want to still comment on this, what if when, assuming I'm having my mirror here like this. Please, I want us to learn this such that when you got the ray diagrams, we just understand what's going on here. So the plane mirror is there like that. A plane mirror is there. There are mirrors used at home. Okay, like we have these local scratchers with that mirror in front. It's not called a plane mirror here. So now what if when the body is in not a point object, the body is like this? What if when the body is like this? This is now the object. How does the rays, how do the rays move to give us the image? So the rays from the top of the image, the object, will go and strike the mirror at that point, like that. Then at the same moment, okay, we'll go and strike the mirror at that point. The rays are moved like that. But from laws of reflection, every ray which strikes here is reflected back in that order, like that. Then again, the rays and any ray which is reflected back in that order appears to be coming from a certain point up there. Now another ray will come from the bottommost part of the body of the object and will strike the mirror at that point, like that. And from laws of reflection, once the rays are incident on the plane mirror, these rays will be reflected back in that order. They should be parallel around there, like that. Then what happens is, this ray appears to be coming from a certain point. This ray appears to be coming from a certain point, I, like that. But again, don't you think there are other rays? Don't you think there are other rays which are coming from this side? Okay, maybe there is also another ray which comes like that. This ray is reflected in that format, like that. And this ray appears to be coming from a point around there. Then also another ray from here comes in that order, is reflected back using laws of reflection. This ray appears to be coming from another point, say here. So you find that these two rays meet around here, and now another image I will be formed right there. So you can either use this one of a point object, or you can use the one of, okay, a finite object. And now, since they're talking about a human being, then this was a better option, using a finite object. I'll raise up this off and we proceed. So let's start with, now we are answering part A of the question. They're saying, let's start off. So now let's deal with the mirror at home. Mirror at home was a plane mirror. Let's get it here. So that is our image, and now that is more like the person they are talking about. So let's get our plane mirror here. Our plane mirror. So actually that's our plane mirror. Okay, as explained, we have that ray coming in that order, in that direction. Hope we are clear there. That ray will be reflected in that order, like that, in that direction. So appears to be coming from a certain part up. I explained that. So another ray from the head, again, two rays from a part come like that, in that order. We have that arrow. Then it is reflected back in that order. Then, now what you must know is that here they must be parallel. I think that here they must be, okay, look here, they must be parallel. These rays here must be parallel to each other. Let's proceed again. I hope we are moving in step. I'm putting the arrow. Direction is highly called for, and that ray appears to be coming from a certain point up. Now you must make sure that these rays here, the reflected rays, appear to be coming from a certain point and they intersect. So we have another ray from the bottommost part of the object in that direction. Then it will be reflected from the laws of reflection in that direction. Then it appears to be coming from a point somewhere behind the mirror. Then what happens next is that another ray still comes from the bottom of the object in that direction, and it is reflected using laws of reflection. Then it appears to be coming from another point up. Okay, that is, it appears to be coming from a point behind the mirror, like that. Now these 2 points of intersections here will give us the image. These 2 points of intersection give us the image of that woman as she was viewing the tooth inside her mouth. This is how she was able to view. Now what you must know here is that the way the tooth appears in the mouth is the way the tooth will appear in the mirror. Then too, the distance between the mouth and the mirror will be the very distance between the mouth, between the mirror and the image. And that's what you're going to write. Have straight away. Let's get there. Okay, now that's our eye, assuming this is our eye. Remember, she has 2 eyes. Okay, good. She has 2 eyes, so we are viewing from right here. And now please, this is the image you are going to form, like that. So let's give the naming. We have an object there, and that one is our image. So please, possibly at home, this is how she was able to see everything. Why? She used a plane mirror. Properties: plane mirror has form, the image is upright, meaning the head is up, and the image is the same size. Okay, same size as the object. The image distance is equal to object distance from the mirror. All right, good. Then too, the image is also virtual, meaning the image cannot be casted onto the screen. Let's get the writing about that. All right, good. Okay, maybe first of all, what you're going to do here is, let's see, we want to compare mirror at home, then let's see at the clinic. So at the clinic, let's see. At the clinic, let's see. Sorry, we have a network problem. This JoyoShare software is disturbing us, but anyway, there we move. Regardless, we move. All right, good. So with this, now we okay. When you're doing a plane, okay, remember we had the concave mirror and the plane mirror. Plane mirror is done. Then let's see how a concave mirror goes. Now, a concave mirror, I'll try to give a brief intro here. Assuming we have our plane mirror, a concave mirror here like this. That is up. Okay, just giving a rough sketch of this. So maybe we have our focal length, principal focus F, and radius of the curvature, center of curvature C. Now remember, we don't know if she saw. Remember, the only part where the plane mirror, of course, remember they said somewhere that her face appeared bigger. Her face appeared bigger. Now it means that appearing bigger, it means that the face was magnified. And the only point where the concave mirror can form a magnified image is only if the object is between F and the pole. When the object is here, is when it can form a magnified image, and it will be virtual and also upright. Remember, a concave mirror sometimes forms what we call inverted images. Inverted meaning when the image is facing downwards like that. So with this, it must form a virtual, magnified and upright image. So from here, the rays will come from the object, strike the mirror, they will pass through the principal focus F, then it will be appearing to be coming from a certain point up there. Then another ray is drawn from the center of curvature, here to the top of the image, up to where the rays intercross with the other first ray which came from the principal focus. Now here, dotted line where the two rays intersect shall have an image there. Now I think that this image here is bigger than the object. That's magnified. That's why her face appeared bigger and even the eyes were big. I hope it was even very funny. Anyway, I think let's get this erased off and proceed. So with that, we shall have mirror at clinic. That is a concave mirror. Let's go there. We have a concave mirror right there. We have a concave mirror right there. Okay, that's our F. Okay, let's put the shadings to show that indeed it is a concave mirror. I've clarified very well, and I said, please, a concave mirror only forms a virtual magnified image when the image is put between the pole, or the image is when the object is put between the pole and the principal focus F. Let's have that as F, and that is our center of curvature, please. This one here is the center of curvature. This one here is the principal focus F. Hope that makes some sense. Right, good. So, without wasting time, let's see how our image is going to be placed. Now, I think why am I placing my image there is because they said the face became bigger, which means magnified. So, the only way, or the only part or scenario where we have a magnified image in plane or in concave mirrors is when we have the image, the object, when the object is placed between the pole and the principal focus. Between the pole, this one is the principal focus, this one here is the pole of the mirror. So with that, let's see how the rays go. So the first ray strikes the mirror at that point, in that direction. Then from there it passes through the principal focus F in that direction. Okay, sorry. Okay, it comes like that. And it appears to be coming from a certain point the other side. However much the arrow should move like that. Now I think, okay, this might be proper. I told you the network is disturbing us, but it should be like that. Okay, good. Now, it appears to be coming from another point. Now, another ray will come from right here on top of the image to intercross with this. Then we shall form our virtual image right there. So, let's go there and see. So, we have another ray which passes on top of the object and via the principal, rather the center of curvature. Now, look. This is where they intersect from. So our image will be formed right there. I think let's go there. And now since this is a virtual image, you're going to use dotted lines. Let's see that. So it goes in that order. But the principal focus, we know that the rays come, and when they reach at the pole, since this one is a shiny surface, some rays are reflected back, while as it's coming back, it appears to be coming from a certain point behind the concave mirror. Like that. Then let's see how our image is formed. So that's our image. I think that this one here is small and the image is bigger. That's why her eyes became even bigger. That's what the meaning here in the question. Alright, good. Let's, I think, proceed. With that, let's put the naming. That's object O, and that's an image I. Let's now go and see this in writing. Take note, please. In a concave mirror, the shading is done on the outside. This is the reflecting surface. I hope that makes some sense. Okay, good. So let's see this in writing. So we say the mirror at home, we are talking about this. The mirror at home, in bracket, it's a plane mirror. The image produced is of the same size as the object. It is upright, the same size of the object. You see that this one here is the same size with this. Okay. The next, it is upright. Upright means you see that head is up and even head is up. It is upright. The next, it is virtual. Virtual meaning that you see whenever an image is formed using dotted lines, it is always a virtual image. In fact, this would have been dotted lines, but I've just wanted to make it clear. That's why I left it like that. Virtual as in the diagram. So that's how a plane mirror works. How does a plane mirror work? It forms virtual, upright, and same size image as the object. Now, what about at the clinic? Let's talk about the mirror at the clinic. Okay, good. At the clinic, the concave mirror produces images which are magnified. Upright. You see, upright means head up, even the image head up. Magnified, the image, the object is smaller than the image. The image is bigger than the object. So, and virtual dotted lines. when the two dotted lines are intersect to form an image, that's a virtual image, because virtual images, those are images formed due to apparent intersection of light rays. Then real images, those are images formed due to actual intersection of light rays. And please, virtual images are always found behind the mirror in either case, of course. Okay, good. Okay, when the object is between, okay, virtual, and when the object is between the focal point and the pole. I've clarified from that right from the start. Please, this answers our part A here. This is just, okay, this is just, sorry, this is just part A. We have answered it. Now let's go there and see what else do you think these people want. Maybe let's go and see what are these mirrors in real life. Let's go back there and see. These mirrors in real life, you have that. Now that's the plane mirror. You really see that? A plane mirror. You really see that? The person here is the very person in here. It is upright, same size. That's the plane mirror. Plane mirror. Then a concave mirror. Let's see. Okay, a concave mirror is here. You see that? It makes the thing to appear bigger. You see this house? The house is appearing. The near point appear big and a bit bent, and a bit curved. If you can really see. Now this one here is a concave mirror. This one here is a plane mirror. I hope that makes some sense. Let's go and see now what do they need in part B. Let's go and see part B. They're saying part B, use the graph to support your explanation to the mother about the nature of the image of her face when she tried to look through it. Now the nature of the image of her face is about magnification, the image becoming bigger. That's what I mean. And now our answers will rotate from that. But again, if you have to use a graph, then you're going to draw. Remember, the mirror which made her face bigger was a concave mirror. So we're going to use this one here. Radius of curvature is 20, but we know that from R is equal to 2F, we shall be able to get the focal length F. With that, remember, when she placed her face about 6.0 centimeters in front of the mirror. Now, when she placed her face in front of the mirror 6.0, this one here is the object distance U, which is 6.0. And that's what we're going to use to draw our proper graph. Let's get there. Good. Let's get there. Okay. So first of all, that's our principal axis, which we're going to use. We're going to put everything on the graph there. And that's our principal axis as usual. So let's get it writing here. First of all, we know that radius of curvature equals to, which is the same as, by the way, the symbol for radius of curvature is small r, here like this. Okay, symbol for radius of curvature is small r. Okay, small r, and is equal to 2f. That is a formula. We know it from light. Then we know that, but radius of curvature is equal to 20 centimeters. Therefore, when you substitute in here, the r, the 20, you put it here, that's what you have here, is equal to f. How shall we get f? You divide both sides by 2, both sides by 2. These two will cancel, and this will cancel this to give us a 10. Meaning, the radius of the focal length will be 10 centimeters. And now focal length, how are we going to put it? Our mirror is right there. Okay, we have our mirror right there. We are drawing it. Our concave mirror. Please, this is the very one we had the other side, but this time round, we are going to use a graph to have it displayed here. Now that's our pole. Why you put a pole is, in fact, so long as this one is appearing, it shows the concave mirror. This one here is the pole. We make it a bit longer in that way such that it can be better. Now what you should know is that whenever you have this and you have a plane mirror right there, you must know that if you have your focal length F and center of curvature C, now if focal length is 10, from here up to here will be 10. But remember, if from here up to here is 10, even from here up to here should be 10. The focal length should be this. From focal length to the pole must be equal to the distance from here to here must be equal to from here up to there. So it means that here it must have a 10, even here a 10. And realize that if you add from here to here, you get a 20. Of course, radius of curvature. Okay, and now let's get that here. So that's our F. That's our F, and that is our center of curvature. Now, remember here, this 10, my graph could not accommodate the 10. So I had to bring in a scale. And I said that in the horizontal axis meaning from here up to this side, that's the horizontal axis. That's what I'm meaning there. Okay. That's what I'm meaning by horizontal axis. Okay, good. Now, here what you mean is, in simple terms, here, now, however much here, I say now horizontal axis, 1 unit represents 2 centimeters, it means that whenever you see 1 unit like this, it represents 2 centimeters. So what does it mean? If I have 10 centimeters, then I'll need 5 units. Let's see that from here up to here, that is 1, 2, 3, 4, 5. But remember, each here is 2, 2. That's what I'm meaning by my scale. Each here is 2, 2 centimeters. 2, 2 centimeters. And if you add that, you get 10, which is same as focal length. But remember, if here you have 5, even here I must have 5. So again, 1, 2, 3, 4, and 5. So they must be like that. 5 here, 5 there. But each 1 unit. A unit I'm meaning from here up to here. That's 1 unit. It has having 20 or rather 2 centimeters. So with that, let's start off. But remember, in order for magnified image, the object must be around between the pole. This one here is the pole. Must be between the pole and the principal focus. Once you put it there, then you have a magnified image straight away. So with that, let's start off. So the object distance, remember, was 6 centimeters. But to bring 6 centimeters here, remember, 1 unit has 2. So it means that here we are going to use 3 units. 3 units to get the 6 centimeters. Because remember, from here we have 1, 2, 3. But remember, each is having 2, 2, and 2. If you add it, will be 2 plus 2, 4 plus this 6. So the image must be right on this line here. That's where our 6 centimeters will fit. Please, a graphical method of ray diagrams is done according to scale, not just placing anywhere. I'm placing at 6 centimeters because that's the object distance as explained earlier alone. So let's do that. The image will be there. The object will be right there. So the image is incident onto the plane mirror in that direction. Then it will be reflected back to pass through the principal focus in that order. But it appears to be coming from a point behind the mirror like that. So it goes in that direction. It appears to be coming from a point behind there. The next, another ray will pass through this. Will pass through this via the head, through this, and intersect with that above. So let's see that. Another ray passes through that, and they intersect somewhere this side. Now the image is going to be formed here. It should be dotted, just like we had it in the first place. Alright, good. So with this, let's see. Shall now have our in that direction. But like I explained, this one, the ray which passes through the center of curvature, this ray first of all comes. Why is this one pointing in this direction? This one is a plane mirror. Please, this line is showing that we have this mirror everywhere this side. So once the rays come, this one is a shiny surface, it is reflected back. But as it is reflected back, it appears to be coming from a certain point this side. Sometimes some books use dotted lines here, no harm. You can as well use dotted lines here, no harm. Okay, so with that, let's have our image. So right away, that's our image. Now we have used the ray diagram to show how our face became bigger. You see that the object is here small, the image is here big, and that's how our face became bigger. In fact, the face became magnified. But I want us to clarify why. Let's have that in writing. So it's that the nature of her face was virtual, upright, and magnified. The magnified is one which makes it to be bigger. Virtual, it's behind the mirror. Virtual means that it cannot be cast onto the screen. Upright means that, it was not upside down in simple terms. Okay, and with that, this marks the end of this video of ours. Thank you for watching. Please, at the end of this video, we are going to have another video about set theory, which will pop up there. It's a playlist of set theory. Be there to watch it so that you really know the full notes of set theory. Okay, good. Okay, so let's get this done. Let's get this done. All right, close the chapter.